Okay, so let's go ahead and talk about the F distribution, and then we'll go ahead and apply some tests to it. So some facts are the curve is not symmetrical, but it's skewed to the right. There is a different curve for each set of degrees of freedom. The F statistic is greater than or equal to 0. And as the degrees of freedom for the numerator and for the denominator get larger, the curve becomes approximately normal. Other uses for the F distribution include comparing two variances and two-way analysis of variance. Two-way analysis is beyond the scope of this chapter. So there is a two-way, and so we're only going to be using one way. And even if you go to your Excel spreadsheet, to your data analysis tool, you will see one way and two-way, or one factor, two factor, and you will, in this class, you'll have one factor. When you get a little bit more beyond this class, like your research methods course, then you'll probably move into a two-factor method. Okay, so here's an example of the curve. And we can see as the degrees of freedom increase, that this peak here moves from here to here to here, and then as the degrees of freedom increase, we could see that this is going to eventually get to be normal. But it would have to be quite large in order to reach there. That's why we just automatically just use the F distribution. How do we set up the hypothesis? So we set up the hypothesis easily, right? Like we talked about before. Either all the population means are assumed status quo, nothing's changed, no difference, or at least one of the population is different. Okay, so let's try, let's go into testing a little. So when we're testing ANOVA, know that the ANOVA methods are robust, so small departures from the normality requirement will not significantly affect the results of procedure. That's why we kind of always say approximately normal, because we know little deviations from normality will be okay, we'll end up with the same results. And the requirement of equal population variances does not need to be strictly adhered to, especially if the sample size for each treatment group is the same. So this is really important because this was an additional requirement that we needed all those variances to be the same, but they're saying that if the sample size for each population is the same, then we're going to be okay. Like then there's not a lot of deviation happening because we're grabbing the same number of subjects for each of the populations. And then the last thing would be that one way that we can verify the requirement for equal population variance is just take the largest sample standard deviation and make sure that it is no more than twice the smallest. So essentially, what you're going to be doing is just take the largest standard deviation and make sure that it's no more than twice the smallest standard deviation. Okay, so here's an example of mint pennies. Notice that we have 11 pennies for each year. And they don't really tell us anything about the populations. They just say, here are some penny weights in grams, and that's that. So we have to make sure that each of the populations are approximately normal and samples are independent, and also that extra one, the variances, right, should be the same. So, so the first thing we want to do is make sure to verify the requirements are there to perform a one-way ANOVA. Okay, so first let's talk about the populations. So with the populations, we know that the first thing is all the sample sizes are the same, right? So that was of 11, and we know that that would be no more than 5% of all pennies. Okay, so I do think that 11 pennies from each of those years is quite less than the population of pennies in those years that exist. Okay. The other one was the sample size. So remember that because n sub I is equal to 30, is equal to 11, that is less than 30, right? So we say, oh no, and so what do we usually do? We usually need a box plot and a normal plot. So you could see that I went ahead and did the box plot for you, and you could see that the box plots here have no outliers, and so you're okay there. And then the normal probability plot, I went ahead and graphed them all here. Now I used a specific statistical software called Minitab, and I was able to just put in these and spit them out pretty quickly. And so we can see that they all lie, and this is notice a normal 95% confidence interval. So you can see that all of these lie within that 95% confidence interval. So we have no outliers. And so you're okay on the box plots. Okay, and so the next thing, remember, like, these are just the preliminary criteria anyways, no matter what chapter we're in. But now we're in ANOVA, so let's go ahead and do ANOVA requirements now. So ANOVA requirements mean that all the variants have to be the same, right? That's like the biggest one. Well, they're not the same, right? If I go ahead and zoom in here, I can see it's pretty small, I know, but we could see that the standard deviation is here, here, and here, right? And so we can see from here that if I squared the standard deviation and each one, it would, because the standard deviations are all different, the variances would all also be different. But remember that that's okay. And what were the two criteria of why that was okay, right? Because the first one was that all the sample sizes had to be the same, which they are, right? Same size. And the second part is that the largest standard deviation has to be no more than twice the smallest standard deviation. Okay, so let's look at the largest. The largest standard deviation that we have here that I could see is the 0.02 427. And I guess the question would be, would this be no more than 2 times the smallest standard deviation, which I can see is that last one of 0.01414. And it is, because that ends up being 0.02427 is no more than 0.02828. And sure enough, 0.028 to it is larger than 0.202427, so that criteria is met. So even though the standard deviations on your ANOVA analysis may not all be the same, that's okay, because if the sample sizes are the same and the largest standard deviation of the samples is no more than 2 times the smallest standard deviation of the samples, then it's okay. The population variances, it's okay, there's a little bit of a deviation. So as long as these 2 criteria are filled. So the ANOVA requirements are satisfied in addition to the population requirements.